Okay. Okay, one call came from sir, so I had to go. See, see this. You see this structure. This structure. You can now observe. See, this is a typical column, right? This is a typical column, and you see this is a I beam, and in this I beam you see another one I beam is attached. Have you noticed? See, and you see there is a support over here. There is a support over here, and this column is fixed with some base plate at the ground. And you see there is a load being acting over here, there is a load being acting over here, correct? So you see what is happening in this case. You see in this case, if you want to idealize this structure, you will have to idealize this structure. Can you analyze this structure without idealizing? No, because you will have to model this structure first and you will have to idealize this structure first. So if you want to idealize this structure, then you see this column is basically will be attached to a fixed support. This column will be attached to a fixed support, and after that you see there is a beam, and this beam, you see in this case you notice this support, and you see this support will be just giving it fixity. There is a fixed type of connection will be happening to this this column to this beam, and thus there will be a kind of fixity over here, and then there is a beam, and you see the beam is extending beyond this point. So see, load is not acting at the end of the beam, instead the load is acting from somewhere which is acting vertically at some point over here. So you see the load is acting over here, and beyond the load there is an extension of the structure. Have you got it? So you see this is basically called idealization of structure, and this idealization of structure, to be more in more precise form, if you see, then it will be called as modeling of a structure. So see what you have done. You have idealized, you see, you have idealized this I beam, this column as a vertical member, right? You have idealized this structure as a vertical member, and in this idealization process, what you will give? You will give what is the area of this member. You will give what is the moment of inertia of this member. You will give what is the material property of this member. What is the Poisson's ratio of this member? Are you getting? So what you will have? Ideally, you are making a straight line, you are taking a vertical line, and you are saying this vertical line is having area this much, moment of inertia this much, moment of inertia about x axis this much, moment of inertia about y axis this much, and you also observe this column is basically getting attached to a support which is basically a fixed kind of support. It's a fixed kind of support. And on the other hand, you notice when there is a beam coming over here, the load will be idealized to act just from this point. So this is actually your idealization, and this is actually your modeling. So you see, when you idealize this beam, what you are doing? You are just drawing a horizontal line. However, this horizontal line will not give the modeling of the beam. So to model the beam properly, what you will have to give? To model the beam properly, what you will have to give? You will have to give the details property of the beam. So you will have to write down what is the area of the beam, what is the moment of inertia of the beam, what is the material property of the beam, what is the Poisson's ratio of the beam. So all the relevant material properties and all the relevant geometric properties you will have to give for this beam. Then only your structure will be properly idealized, and then only your structure will be modeled properly. So this is very, very important, because you see the point I am trying to make here, the real life structure may look something. So you cannot just capture a photograph of the real life structure and just put it inside your design code or inside your design software to analyze the structure and design it. So, first thing you will have to do, you will have to idealize the structure and model it properly. Now, you see it is a very simple structure we have seen, right. Now, let us go to the next structure. See this one, it is a very huge structure, looks like a huge structure, right. So, how do you idealize it? It is very simple. So, you see, sorry, how do you idealize it? It is, you see, the idealization will be done for this structure in a very simple way. You see, oh, see this way. This is a big structure, you see, big structure, but what is this big structure made up of? This big structure is made up of one by one column attached, and that is a continuous column, and then there are continuous beams. So, you see, there may be multiple columns in this direction. So, one beam, one column, two column, three column, four column, and the columns are attached to the beams, columns are attached to the beams, or beams are attached to the columns, whatever you say, and this is your floor level, and this is your floor slab, this is your roof slabs. On top of the beam there will be roof slabs. In between two beams and in between the floor slabs there will be columns, and the columns are continuous in nature. So, in one direction this is like this. The same kind of thing will be there in various directions, and there may be multiple this kind of two-dimensional frames. So, while modeling this big structure, what you will have to do, Smriti Anand, now see. So, while modeling this structure, see what you will have to do, you will have to part by part break up the structure in different frames. So, this structure will be made up of different frames, right. So, while idealizing the structure, you will have to break it up into multiple frames, and then you can analyze the multiple frames separately. So, basically you see this big structure also needs to be idealized to a simpler form like this. Have you understood it? Very simple. It looks to be very simple, but it requires lot of expertise. Okay, and gradually when you will be learning your structural analysis course, and when you will be doing the analysis using design softwares and others, you will be getting more clear on this. So, you must understand this modeling and idealization concept very clearly, because without modeling and without idealization you cannot model a structure. And while modeling, you must remember the idealization of the structure must be proper. While idealizing the structure, if you miss any condition of support, then you may be getting your result wrong, and in such case your analysis result may fail. So, this thing you should very carefully observe and note it. Who is Supratim Mukherjee? He is from our class.
Yes,
Yes,
sir.
sir.
So,
Yes, sir.
maybe he left. I am admitting. Okay. Yeah. So, see. So have you understood now the concept of modeling? So, see, modeling is nothing but making the structure into a simpler form through which we should be able to analyze the structure easily. And while modeling, it is very simple that you will have to model your different parts of the structure, and while modeling you will have to take the load carrying members of the structure, and those load carrying members needs to be modeled in such a way that their material properties, their geometric properties, all the things are embedded inside that modeling process. Next, if you go to the idealization of structure, again idealized structure, you see you have done this in your strength of material course. What you have done? You have analyzed this structure, right? A simple supported beam. All of you have done it or not? It's a simple supported beam. So, there is one end. Should I make it little bit larger? Let's see. Yes. See, I made it little bit larger. See, See this beam, this one, this structure, you have analyzed or not? You have analyzed this structure?
Yes, sir.
It is a simple supported beam, but from where it is it coming? It is idealization of some real structure basically. So what is idealization of real structure? You see, if I go little down for this, see this one, if you see this bridge structure, have you noticed this bridge structure? So you see, in this bridge structure I will make it little bit larger, so you will be understanding it more clearly. You see, if I go to this, see this bridge structure, if you take, see if you notice a bridge structure from the bottom under the bridge, not from the top, from the bottom of the bridge. Okay, so you will observe that at one end some bearings or the rollers are given, at the other end you will notice they are basically fixed, or some kind of support is given where no movements are allowed, whereas on the other end you will notice there are some movements allowed, and those are basically roller supports. So rollers associated bearing pads. So what is this called? The bearing pads. You will observe in a bridge structure there are bearing pads, okay, and the bearing pads are basically the rollers, okay, and are used to support pre-stressed concrete girders of a highway bridge. It's not only true for pre-stressed concrete bridge, it is any kind of bridge if you take, it will be supported on pre-stressed bearing pads, and those bearing pads will be basically supported on some rollers, and those the rollers will be supported on those bearing pads, and thus any bridge girder, that means the total bridge slab which is supported by these rollers and this pin support, you see this will be idealized actually like this, or finally it will be idealized to this one. So basically it will be idealized to a beam which is nothing but a simple supported beam, and in a simple supported beam, see at one end there is a pin connection and other end there is a roller connection, and here it is being shown as a point load, because this actual beam is being idealized like this, whereas in case of a bridge structure or a bridge slab, if you want to idealize, there may be some kind of uniformly distributed load coming onto this beam along with some kind of live loads coming onto this structure. Okay, so these points of idealizations are very important. Now next let us go to some more thing on idealization. You see, these are some diagrams again of some supports of idealized structure. You see, this is basically a cable attached to something. So you see, when a cable is attached to something, it will make some angle theta, and you see this theta angle, when it will be idealized. See what is being done over here. The cable is being attached, this light cable, the cable structure, when you will analyze, you see this light cable is attached to some link, and this link is nothing but taking a reaction which is basically being coming from this light cable, because this light cable is going to give some tension on this, and thus there will be some kind of vertical reaction which will be aligned to an angle theta. You see, this vertical reaction will be along this, it will be along this, it will not be horizontal, or it will not be vertical, because the cable structure will be under tension. So whenever there will be a tension, there will be a reaction coming onto this along this the cable structure at an inclination of theta. Okay, now you see, if a structure is smooth pin or hinge structure, you see, in a smooth pin or hinge structure, if you see, in that case you notice this is a smooth pin or hinge structure, a member is attached to it. So you see, there is an angle horizontal with an angle, it is making an angle theta. So you see, if a member is somehow attached like this, and it is inclined at an angle theta which is the horizontal. So, you see in the pin, if I idealize this one, if I idealize this support as a pin, then it will become like this, and you know what happens to a pin. A pin will have two reactions in it. So, there will be Fx and Fy. Is it clear? Now, if you come to the roller support, you see this is a typical type of roller support. So, rollers can be different types. You see, ideally when you observe the practical problems, your rollers may be something looking like this. So, see 3 roller supports, then there may be some kind of rolling mechanism given like this, and there may be some kind of support which is basically just a kind of rocker support, and this rocker support is basically kind of a support which will be able to move in this direction and this direction. So, all these three kinds of supports, you see finally is going to give you a vertical reaction. It is going to give you a vertical reaction, because you see this support, if you are idealizing, this will allow your horizontal movement. This support, if you are idealizing, it will allow your horizontal movement. This support also, if you are idealizing, this will also allow your horizontal movement, because rocker support, it will just move in this direction and this direction, this direction and this direction. So, it will allow the horizontal translation, as well as it will allow the also the rotation. So, which action, which one will not be allowed? The only thing it will not be allowed in this kind of supports. So, be it this type of roller, be it this type of roller, or be it this type of rocker. So, any kind of this kind of support, if you want to idealize, you see the idealized structure will look like something like this. So, there will be only one vertical reaction. Is it okay? Now, next is this one. See, I will make it little bit smaller, just a minute, little bit smaller. Yes. So, now you see this is basically a slider. You see, this is basically a slider. So, you see this one, you can see this, there is a roller kind of thing, there is a roller kind of thing here, there is a roller kind of thing here. So, what is happening to this support? What is happening to this support? This support can vertically move down like this, So, basically this is a slider. Okay. So, you see, if you want to idealize this structure, what will happen like this? What will happen to this structure? There are rollers on this, and a beam is attached to this, and which can move downward in this direction, but because the slider is protected against some support at behind this, it will not allow this member to go in the horizontal direction. So, what will happen when you idealize this kind of slider, or if you want to idealize this fixed connected collar, this kind of structure, rather you just understand this slider only. So, if you want to idealize this slider, you observe this is very important. See, this is little different than this one. You see, this is little different than this roller. The slider and roller are different. See, in case of roller, you have got only vertical reaction, whereas in case of slider also you are getting a roller support. But you see, because this beam is there in between this slider, what is happening? See, this beam is not allowed to move in this horizontal direction. So, there will be a horizontal reaction coming. On the other hand, you see, this beam is not allowed to rotate in any direction, and thus if there is no rotation, what I said, if there is no rotation, there will be moment coming. So, there will be a moment coming in the structure, and you see there is no vertical reaction. So, do not think that roller means there will be vertical reaction coming always from the y direction. See, in case of slider support, where the roller is moving in the vertical direction, the reaction will come in the horizontal direction. So, to point out here one point you must remember, that is, whenever you are considering a roller support, you must observe the direction of the roller, and if the roller, the reaction will be always acting in the perpendicular direction to the roller. So, see, the roller is in this direction, so reaction will be coming perpendicular to this direction. Roller is in this direction, so reaction will be coming perpendicular to this direction. Okay. So, I hope you have now got the understanding about different supports. Now, let us go to the last kind of support. So, let us say this support, if you see this one, or rather you see this is smooth contacting surface. So, let us say you are putting a member, let us say, have you noticed while erecting any pandals or something like that, a bamboo is being placed something like this in an inclined way. So, just on the ground, just it is being placed. So, in such case, if you want to idealize the structure, what kind of reaction will come? See, there will not be any horizontal movement, there will not be any vertical movement. So, only thing, see there, this when you will be supporting this kind of inclined structure, see there may be little bit of horizontal movement allowed in this direction. So, there will not be any vertical movement allowed in this direction. So, in case of smooth contacting surfaces, always you are going to get the idealized structure which will something look like this. So, there will be a vertical reaction. So, see this and this looks to be same, but their support conditions are different. However, their final idealizations are exactly same. See, this support and this support looks to be same, but see this support's idealization is different than this support or this member's idealization. Now, coming to the last point, you see the fixed support. So, in case of fixed support, you see this beam is fixed to something, and while idealizing the fixed support, what you will have to do in a fixed support, you see all the directional movements will be restricted. That means horizontal translations will be restricted, horizontal vertical translation will be restricted, as well as the rotation will be restricted. So, you are going to get 3 reactions in any fixed support. So, there will be Fy, there will be Fx, and there will be M. So, Nitik Singh. So, all these things you will be getting, all the 3 reactions you will be getting in case of idealizing a fixed support. Now, next coming to this equilibrium, I think Ankita madam has already spoken about equilibrium and determinacy, but I will just tell you briefly about this equilibrium and determinacy. So, you see when you talk about equilibrium and determinacy, then you see for a general 3D equilibrium, what you are going to get. So, whenever there is a 3D structure, 3-dimensional structure, so whenever there is a 3-dimensional structure, forces will be coming from different directions. So, 3-direction forces will come. So, in a 3-dimensional equilibrium, always you will have to solve 6 equations. So, you are going to get 6 equations of equilibrium. You are going to get 6 equations of equilibrium in case of a 3D structure. What are they? Fx, sigma Fx equal to 0. So, all the horizontal forces, all the forces in x direction should be equal to 0. Summation of all the forces in x direction should be equal to 0. Summation of all the forces in y direction should be equal to 0. Summation of all the forces in z direction also should be equal to 0. On top of that, the summation of the moments in the x direction should be equal to 0, moments in y direction should be equal to 0, and moments of z direction, moment about z direction should be equal to 0. So, moment about x, moment about y, and moment about z, all the 3 moments will be coming in a 3D equilibrium. Okay? So, 3D equilibrium is little bit complex. So, in many cases structure are simplified and idealized as 2D structure. Okay? So, structures are idealized and simplified to make it a 2D structure, and thus your simplified equations of equilibrium will become 3. So, what are those 3? So, those 3 will be summation of all the forces in the x direction equal to 0, summation of all the forces in the y direction equal to 0, and summation of all the moments equal to 0. So, these are the this is very important to understand. See, if you are given a 3-dimensional structure, you cannot get only 3 equations of equilibrium. For a 3D structure, how many equations of equilibrium you will have to solve? You will have to you will have to get how many equilibrium equation you will get? you are going to get 6 equilibrium equations. Whereas, so 6 equilibrium equations and then solving those 6 equilibrium equations is very difficult. So, in many cases structures are simplified and idealized as two-dimensional structure. So, that is what I have shown you here. So, you see in this case this is a very big building, you see there is a very big building. So, there will be this cannot be a two-dimensional structure, this is obviously a three-dimensional, right. So, every structure is a three-dimensional structure, but what we are doing, we are making it simplified to this kind of frames and multiple two-dimensional frames we are making, and then we are idealizing this big structure as two-dimensional by making simpler frame structures and then finally adding up those frame structures and analyzing and putting some conditions on those to get the final value of bending moment, shear force, reaction, whatever it may be. So, once you make it a two-dimensional structure, how does the things become simpler, you can understand from here. So, for a 3D you are going to get 6 equations, whereas for 2D you need to just solve 3 equations of equilibrium. So, obviously your life will become easier. So, if you can idealize your structure, for the what is called, if you can idealize your structure for 2D structure, then your life will become simpler and you can analyze it in a very easy way. Now, just another 1 or 2 slides I will just show you. Our time is over, almost it is over. Okay. So, let us stop here today. Okay. So, have you understood today's discussion, all of you?
Yes, sir.
Have you got it? Now,
Yes,
now I see. Now
sir.
see what I am. I'm very sorry to see this. See, I have taken the download of 27th class. 27th was what? 27th July. 27th July was Monday. Okay. So Monday I have given you some questions. Do you remember? Who have come to the class? You know? Remember? I have given you some questions, right? Have you got it?
Yes, sir.
See, I am showing this. Okay. So you see this is the answer I got. So how many people? 17. Only 17 people participated. Why this is happening like this? I have given some questions. What is mechanics? What is being studied in structural analysis? What is strength of material? What is structural analysis? What are 3 major purposes of structural analysis? Just one liner or 2-3 words answers you need to make, right? So why are you not participating?
Sir,
Why are you not participating in this quiz?
sir, I have submitted the quiz, but I don't know. My name is not here in the list.
Why it is not coming? So can you please submit again? See, I have kept.
Yes, sir, I have also submitted. Sir, I have asked for.
So see, many people's name are not coming. Have you noticed? So, hello. So can you please submit it again?
Okay,
Yes.
sir.
See,
Yes,
what I'll do, I'll send another one quiz today. Okay, but if you submit, see, I have not closed the quiz. So if you submit, then it must be there. I am still accepting responses. So you see, only 17 responses are coming. So you are saying submitted? No, it is not being submitted. It is not
So
being
again,
submitted.
you will submit it.
Huh? See, you should submit. Huh?
Again, I will submit, sir. Now,
Yeah, you should submit. Okay. So if you get
sir,
a
every
tell.
sir, every quiz we are submitting, sir. I don't know, but in this, my name is not there. I have submitted, sir.
I don't know because
So,
see this is quiz this quiz I have given na. So see
yes, sir.
this thing report is showing only 17 response because I
Okay,
am
so
still
again I
accepting
will
response.
submit today.
See if you get a class of the roll number, okay, if you get a class of the
Yes,
roll
sir.
number, okay, so just omit 120013, just write 18088 something like that, okay, because I don't think there will be class of roll number. Maybe what is happening, I tell you what is happening when you are submitting na, some internet connectivity problem is happening, that's why it is not being getting submitted properly, okay. See, you will have to write the answer and then submit. Are you
सर
writing?
एमसीक्यू टाइप रहेगा तो रिजल्ट भी सब कोई देख पाएगा ना
No,
इससे ये रिस्पॉन्स
I am not going to give MCQ this time because MCQ का क्या हो रहा है, MCQ इधर उधर से सब लोग इधर उधर व्हाट्सएप में भेज दे रहा है और कर दे रहा है. लास्ट टाइम वो देखा मैंने. दिस टाइम आई एम गोइंग टू गिव दिस टाइप ऑफ शॉर्ट ऑब्जेक्टिव क्वेश्चंस एंड आई विल सी कि कौन क्या कर रहा है, थोड़ा सा देख रहा है कि नहीं, पढ़ के देख रहा है कि नहीं, वो आई वांट टू अंडरस्टैंड. So MCQ I will give, but later on, not now. MCQ, see, problem of MCQ is only you are just putting some answer and
एक सिंगल एमसीक्यू रहेगा तो रिस्पांस में शो करेगा ना रिजल्ट, तो इससे अच्छा रहेगा कि सबमिट हो गया है तो सबको रिस्पांस भी चेक कर लेगा.
no response. See, why do you need to check response? See, what I have given some questions, okay, then you fill it up and submit. So if you fill up and submit it should come here. See how these people's responses have come. 17 responses I have got. Anuj Kumar roll number 88, Anuj Kumar roll number 89, roll number 18 Dibakar Chakraborty, these things I have got. So they have submitted. Buddhadev Sadra I have got, Hitik Singh I have got, Krishanu Nag, Jishu Saha, Mizan Haidar, Neelam Kumari, Ayan Chakraborty, all these responses I have received. So I think today's quiz also it will be this kind of quiz, okay. MCQ I am trying to I am little bit avoiding now because see MCQ what is happening, you people are not just putting something and then sending it, so I don't want that. So you please resubmit, okay, that is why I am not closing it, okay. Is it clear?
Yes, sir.
Yes, sir.
Please resubmit. I have not stopped the stop taking responses, okay. So have you given your attendance or you have not?
Not yet.
Not yet. Anyway, I'll take the attendance from here. So how many people joined today? How many people joined today? See, you should give your attendance using that, right? Because your attendance will be recorded in that way. Although attendance is not that important, but Abhishek,
Yes, sir.
CR, see, I know, I observed that only 20 people, 25 people are coming every day, isn't it?
Yes, sir.
Huh? How many people we have? 44.
Yes, sir. 44.
44 we are having, na?
Yes, sir. 45.
45, right? 44, 45. So why others are not coming? You just send a message.
Okay, sir. I will convey this message.
You please convey the message, huh? See, otherwise, I see there will be problem in CA and PCA marks. Tell them very clearly. I will send out a notification, okay, but see, they should attend. See, I know there are 4
So
people.
previously also I have informed them in the group, sir. Previously also that they must attend the class.
Who are the regular defaulter?
Where
Can you prepare a list and give it to me? Please.
Yes, sir.
give it.
Definitely I can give you.
Please.
Okay, sir.
Anuj is there.
Yes, sir. Yes, sir.
You and Abhishek together prepare a list, okay? The list
Okay,
of
sir.
serial defaulters. I think they are not attending any classes, not only the structural analysis. See, leave the 4 persons, 4 students from Kashmir. Okay, they have informed me they are not able to access this
हमारे सामने
3G. Okay. See, Kashmir, from Kashmir there are 3 or 4 students, 3 or 4.
3 students, sir. They don't have any connectivity.
So please leave them. Please leave them from your list. Okay. But other than that, I think many are not coming. So Abhishek, you please try to give me a list. Okay, who are not coming, and send a message to the group also that I told told all to attend. Okay. See, there may be some connectivity problems on some day. In the previous class also, while taking the soil mechanics class for the other section in your class, I also faced problem. Okay, but later on it resolved. Okay, so there may be problem in 1 or 2 days, but regularly people are not coming. That I have noticed. I know I am seeing that few people are coming regularly and few people are not coming at all. So this should not be the case. Okay. So please, Abhishek and Anuj, please inform
sir.
as well as you please prepare a list and give it to me. Okay.
Yes, sir.
हाँ, give it to me. Roll number दे देना, ठीक है? What are the roll numbers? Okay.
Okay,
Or you
sir.
can give name also, whatever it may be. Okay.
Yes, sir.
Okay. So let us stop today here. Tomorrow's class, listen carefully. Tomorrow's class we will finish this introductory part. Okay. And if you have any question from this introduction part, you ask me. Tomorrow's class, half an hour we will keep for interaction, complete interaction, and half an hour I'll tell you the remaining portion of the slides. Okay. And then from the next week we will be moving to a new concept that is called influence line diagram. Till now you have understood the concept of bending moment diagram. Okay. So bending moment diagram, when you draw, it is a load, static load acting on the structure. But if a dynamic load is acting on the structure, okay, dynamic load means the moving load. So in case a load is moving on a structure, then how do you calculate bending moment at different points? That is actually your influence line diagram. So we will discuss, we will take lot of classes on that. So influence line diagram concepts will be starting from the next week. But before that, in the tomorrow's class we will be concluding on this introductory part. If you have any question, please join the keep your question ready in your hand, and then either you can send it through the chat box, or you can do it, you can ask me directly. Okay. So thank you very much. Okay.
Thank you.
Thank you, sir.
Thank you, sir.
Okay, thank you. You can leave.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
I am leaving the meeting. Okay. Thank you.